This is the Unit 4 practice test video, which goes with the practice test that's found beginning on page 305 in your book. Alright, so problem number 1, we're simplifying square root 75. So remember, we need to find the largest perfect square factor of 75, and we can use a factor tree to help us do that. So our factors of 75. 25 times 3 is 75. 3 is prime. 25 goes to 5 and 5. So there's our pair, 5 times 5. There's our perfect square. And the irrational part will be the 3. So using that multiplication property of radicals, we can rewrite radical 75 as radical 25 multiplied by radical 3. The square root of 25 is 5. So we end up with 5 radical 3, or 5 square roots of 3. Problem number 2, negative 3 times the square root of 45. We need to simplify 45, radical 45. So I'm going to do a factor tree for 45. 9 multiplied by 5 is 45. 2 factors of 9 are 3 and 3. So there's our perfect square, a 9. And our irrational part will be the 5. So the negative 3 will drop down. I will rewrite radical 45 as radical 9 times radical 5. And now I'll simplify. I will have negative 3 multiplied by the square root of 9 is 3 multiplied by radical 5. Negative 3 multiplied by 3 is negative 9. So I get negative 9 times the square root of 5. Alright, recall that to take the square root of a variable that has an exponent on it, if it's even, it's a perfect square, and you just divide that by 2. The square root of 49 is 7. The square root of y to the 8th is y to the 4th. Make sure you remove the radical. The square root of x to the 18th is x to the 9th. Now notice radical y to the 15th. Y to the 15th isn't a perfect square, so when we have an odd exponent like that, we can't divide it by 2. We need to use the multiplication property of radicals. We'll take 1 away from the 15th and rewrite this as radical y to the 14th times radical y to the 1st. Then I'll take the square root of y to the 14th, which is y to the 7th, and that leftover radical y will just remain under the radical. So I get y to the 7th times the square root of y. 27 is not a perfect square, but I can simplify it. 9 times 3 is 27. 3 multiplied by 3 is 9. So you have a perfect square 9 with a leftover 3. So I'm going to have radical 9 multiplied by radical 3 multiplied by radical y to the 4th. The square root of 9 is 3. Radical 3 is irrational, so it's going to stay underneath the radical sign. The square root of y to the 4th is y squared. Remove the radical. The 3 and the y squared I will move up front, and radical 3 we can leave it under the radical sign. 3y squared times the square root of 3. Simplify radical 80, a to the 5th, b to the 15th. We're going to have to split up everything here. So factor tree for 80. 8 times 10 is 80. 4 times 2 is 8. 2 times 2 is 4. The 10 goes to 2 and 5. Okay, so we have 2 pairs of 2's and a 5. So a 2 and a 2 is a 4. A 2 and a 2 is another 4, and I have a leftover 5. So I'm going to bring this down a little lower because I have a lot to write the way I do it. So I'm going to have radical 4, radical 4, radical 5. I have to split up my a's and I have to split up my b. I'm going to take 1 away from the a to the 5th. There's my leftover a. Take 1 away from b to the 15th, that's a b to the 14th. There's my leftover b. And now I'll simplify. The square root of 4 is 2. Square root of 4 is 2. Radical 5 drops down. The square root of a to the 4th is a squared. Radical a drops down. The square root of b to the 14th is b to the 7th. Radical b drops down. So we'll write our answer as 2 times 2 is 4. A squared b to the 7th. Radical 5ab. Number 8 also tells us to simplify, but we have two radicals side by side. So actually we're multiplying these radicals together. So we're going to multiply them together first, and then we will simplify. So 6 times 12 is 72. A squared times a is a to the 3rd. B to the 5th times b to the 7th is b to the 12th. If I do a factor tree for 72, 8 and 9, the 8 goes to 4 and 2. The 4 goes to 2 and 2. Notice I have a pair of 2's there, a leftover 2, and the 9 goes to 3 and 3, which is a pair of 3's. So I have a pair of 2's, which is a 4, a pair of 3's, which is a 9, and a leftover 2. So I have radical 4, radical 9, radical 2. I need to split up my a, take 1 away. There's my leftover. I can divide 12 by 2, so I can just leave that alone for a second. Okay, and now I'll simplify. The square root of 4 is 2. The square root of 9 is 3. Drop down radical 2. The square root of a squared is a. Drop down radical a. The square root of b to the 12th is b to the 6th. 2 times 3 is 6. So I have 6a b to the 6th square root 2a. Alright, we're multiplying these together as well. But notice we have 3 radicals in this one. So, when we multiply this together, 5 times 15 times 3 is 225. We have x times x cubed, which is x to the 4th. We have y times y squared, which is y to the 4th. Now 225 is a perfect square. The square root of 225 is 15. So we get 15. The square root of x to the 4th is x squared. And the square root of y to the 4th is y squared. Alright, recall that when you're adding and subtracting radicals, you must have like radicals, so you have to have the same things under the radical sign. Number 10 won't be bad because you can see we have a radicand of 3, so we already have like radicals. We have negative 4 square roots of 3 minus 8 square roots of 3. Negative 4 minus 8 square roots of 3 gives us negative 12 square roots of 3. Number 11, however, we have a square root 45 plus a square root 125. So we're going to simplify each of those radicals first, then hopefully we'll have like radicals and then we'll be able to add them together. So I'm not going to do a factor tree for 45. Once you do a factor tree, you'll have a pair of 3's, which will give you a 9 and a leftover 5. The square root of 9 is 3, so this simplifies to 3 square roots of 5. Now, if you want to do a factor tree for 125, you can. However, we know that we want a radical 5. And we know that 125 divided by 5 equals 25. And that works out really nicely because we can take the square root of 25. The square root of 25 is 5. So we end up with 3 square roots of 5 plus 5 square roots of 5. So it's like undoing the distributive property here, pulling out that square root 5, we end up with 8 square roots of 5. Right, we have a subtraction of radicals with some variables involved. The 5a is just going to drop down. Radical 20 will rewrite as radical 4 times radical 5. The a you're not going to be able to take the square root of. I'm just going to put it with the 5, and we'll take the square root of the b squared. So I'm going to have 5a multiplied by 2. Radical 5a will drop down, and the square root of b squared is just b. 5 times 2 is 10. A, pull that b up front, square roots of 5a. So we want our radicand to be a 5a. On this right-hand side, drop down your 5b. The a cubed, take one away, put the leftover a with the 5. So you have 5b, radical 5a, the square root of a squared is a. So we'll rewrite this as 5ab square root 5a. So we have 10ab square roots of 5a minus 5ab square roots of 5a. So that's 10ab minus 5ab square roots of 5a. So that's 5ab square roots of 5a. All right, and so that concludes radicals, and so now we'll move on to the graphing part. For number 13, we have an A and B. Identify the quadrants in which the following points lie. So let me just draw a little coordinate grid over here. Recall this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So it moves counterclockwise, okay? So the ordered pair 6, -5, if you plotted that point, you'd go right and then you'd go down. So that would put you in quadrant 4. And then for B, 6, 4, you would go right and then up. So that ordered pair would be plotted in quadrant 1. Graph y equals -4x plus 3. Now you have a couple different options here. In our first section of graphing, we graphed by using a t-chart or a t-table. But then in section 4.7, you graph using the slope and the y-intercept. So you're able to use that as well. Okay. So in this first example, I guess I'll just do it for review. I'll just do it by finding it by using a t-chart, since that's the first way we did it. Okay. All right. So if you're going to use a t-chart, remember you need at least 2 points. I like to do a third one. And you just pick x's and then plug them in to find the y that corresponds with them. So you want to choose friendly ones. I'm going to choose 0 to start with. So that will mean y equals -4 times 0 plus 3. That means y is equal to 0 plus 3, which means y is equal to 3. So when x is 0, y is 3. So that's our first solution, our first point on our line. So to graph that, starting at the origin, we go left or right 0, and we go up 3. So there's one of the solutions to the line, to the equation. Okay, I guess I'll choose 1 next. That means y is equal to -4 multiplied by 1 plus 3. So y will equal -4 plus 3, which means y is equal to -1. So another solution is 1, -1. from the origin, that will take me right 1 and down 1. And I'll just do one more. I'll do 2. So that means y will equal -4 times 2 plus 3. That means y equals -8 plus 3, which means y is equal to -5. So 2, -5 is a third solution. And recall, there's an infinite number of solutions to the equation. We need at least 2. I'm doing a third one. So that will be right 2, down 5, 1, 2, 3, 4, 5. Remember, in WebAssign, you only need to plot 2 points to graph a line. All right, y equals 4/5 x minus 2. Now, if you decide to use a t-table, which I'm not going to do in this case, but let me just go ahead and draw a t-table up here for those of you who choose to do that. You're going to want to choose whatever you plug in for x, you're going to have to multiply by 4/5, and you want the fraction to clear or go away. So you'll want to choose multiples of whatever the denominator is, which is in this case 5. So if you choose to graph this by using a t-table, you may want to choose like 0 for x and 5 and -5 perhaps, or 10 and -10, okay? But I'm going to graph this one by well, I'll just go ahead and do this one the same way, okay? So if I use 0, y will equal 4/5 multiplied by 0 minus 2, which equals 0 minus 2, so y equals -2. So 0, -2, left or right 0, down -2. I'll use 5 next. Y equals 4/5 times 5/1 minus 2. All right, and that's going to equal, oh boy, four minus 2. Okay. So that's right 5, 1, 2, 3, 4, 5, and up 2. Okay. 5 times 4 is 20. 20 divided by 5 is 4. 4 minus 2 is 2. Just making sure I didn't make any mistakes. Okay. Now if I put a -5 in, just trying to picture numbers. Maybe I'm going to use a 10 instead. Let me see what a 10 gives me, okay? Let me go to my eraser. Okay. Okay, so that means y will equal 4/5 times 10/1 minus 2. 4 times 10 is 40. 5 times 1 is 5. 40 divided by 5 is 8. 8 minus 2. That means y is equal to 6 here. So if x is equal to 10, y is equal to 6. Oh, why did I choose 10 though? I don't want to choose 10 because I can't go 10 over. That wasn't a very wise choice. I don't know what I'm thinking here. That was not wise at all. X won't even go out that far at 10, right? Okay. My eraser still wants to go. Y equals, I don't know what I did there, 4/5 times -5 over 1 minus 2. I'm just making a real big mess of things here, and I really don't want to start this video over, so this is going to equal -20 divided by 5 is -4. -4 minus 2, y equals -6. That's a little better. Alright, so let's see where this puts us. So that will be -5, -6. So we had a 5, 2. We already plotted that. -5, -6. I'm going to go left 5, 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. Alright. You guys have probably moved on to the next problem. I'm fumbling around. Alright, so you can see that's a good example of just, you want to be careful when you choose your x values, because if it goes off the coordinate grid, it makes it very difficult to graph. That would have been just much easier to graph by plotting the y-intercept and then using the slope to plot an additional point. Alright, y equals 2/3 x. If x is equal to 0, that means y equals 2/3 times 0, which is just 0. So y will also equal 0. If x equals 0, y equals 0. That's going to be a point right at the origin. We want to choose values that are multiples of our denominator. So I'm going to choose 3 and -3. So y equals 2/3 times 3 over 1. So y equals 2. So 3 2s, so that's right 3 up 2. And if x is equal to -3, y will equal 2/3 times -3 over 1. So in this case, this will be -2. So left -3, 1, 2, 3, down 2. So the last examples that I've done, 14, 15, and 16, that's how you can graph a line by using a t-chart or a t-table. Alright, find the x and y intercepts. Remember to find the x-intercept of a line. That's where it's crossing the x-axis. So where it's crossing the x-axis, y is 0. So you plug in 0 for y. Okay, so we're going to have 2x plus 3 times 0 equals -18. But 3 times 0 is 0. So we just have 2x equals -18. Dividing both sides by 2, we see that x is equal to -9. So your x-intercept is -9, 0. Okay. For your y-intercept, we're plugging in 0 for x. So we're going to have 2x, or 2 times 0, plus 3y equals -18. 2 times 0 is 0. So we just have 3y equals -18. Divide both sides by 3, and you see y is equal to -6. So your y-intercept, We plugged in 0 for x. Y is negative 6. What did I do again? Okay. All right, graph 2x minus 3y equals 6. Now, notice that this is in standard form. ax plus by equals 6. And also notice that 2 and negative 3 will go into that 6 evenly. So this is a clue that the best way to graph this is by finding the x and y intercept. So let's go ahead and find the x-intercept. I'm going to plug 0 in for y. So we're going to have 2x minus 3 times 0 equals 6. That goes away. 3 times 0 is 0, so I have 2x equals 6. Divide both sides by 2. X is 3. So your x-intercept is 3, 0. The point right there. And then your y-intercept, we'll plug 0 in for x. So we're going to have 2 times 0 minus 3y equals 6. 2 times 0 is 0. So we have negative 3y equals 6. Divide both sides by negative 3, and you see y is equal to negative 2. So your y-intercept is 0, negative 2. Your x was 0, your y is negative 2. So that's this point right here. So that's the graph of that line. I am struggling today. No, the slide won't move forward. There we go. Okay. Graph the line y equals negative 3. You're having a hard time remembering how to do that. Draw a t-table. Y has to be negative 3. X can be whatever you want. So let's just put a 2 and a 5 in here, say. Plot those two ordered pairs. 2, negative 3, right 2, down negative 3. 5, negative 3, we're going to go right 5. 1, 2, 3, 4, 5, down negative 3. So you can see that that graph of y equals negative 3 is a horizontal line at y equals negative 3. Graph the line x equals negative 5. You can do this the same way. Only now x has to be negative 5. So let's say y is, I don't know, 2 and 4. It doesn't matter. Y can be anything. So that will be left negative 5, 1, 2, 3, 4, 5, and up 2. Left negative 5 and up 4, 1, 2, 3, 4. You can see that that is going to create a vertical line at x equals negative 5. So that's the graph of that line. Find the slope of the line containing the given points. Recall that our formula for slope is equal to the difference in y's divided by the difference in x's. I'll call this x1, y subscript 1, this x subscript 2, y subscript 2. So I will have 8 minus 2 divided by negative 8 minus negative 1. 8 minus 2 is 6. I do a change there, so that's going to be negative 6/7. If you want to just leave the negative on the bottom, that's fine, or it can go out front, or it can go on top. So make sure you have one negative there. Okay? So that's the slope of the line that goes through those 2 points. Same thing here. y2 minus y1 over x2 minus x1. Difference in y's over difference in x's. So I have negative 6 minus 4. 3 minus 3. That's negative 10 over 0. Recall you can't divide by 0. This is undefined. If you plotted those 2 points and connected them, you may want to do that. Remember that you'll have a vertical line. Number 23, we'll do the same thing. x1, y1, x2, y2. Difference in y's minus difference in x's. I have 7 minus 7 over negative 1 minus 3. That equals 0 divided by negative 4, which is equal to 0. And if you graph this line, you would notice that it's a horizontal line. A horizontal line will always have a slope of 0, and a vertical line will always have an undefined slope. Graph the line that passes through the given point and has the given slope. Okay, so we just need to plot negative 3, 1. So that's left 3, 1, 2, 3, up 1. And then remember the slope is rise over run. Rise 4, 1, 2, 3, 4, run 5, 1, 2, 3, 4, 5. Let me just double check it. 1, 2, 3, 4, 1, 2, 3, 4, 5. And our last problem, graph by using the slope and the y-intercept. Notice it's already in slope-intercept form. Y equals mx plus b. So our y-intercept b is negative 3. I can plot that point. My slope m, that's your rise over your run. We can either write that as negative 2 over 3, or we can put the negative with the 3 at the bottom. It doesn't matter. Okay, I'm going to go ahead and use this slope to start with. Okay, so I'm going to rise 2. So I'm going 2 up, and I have a run of negative 3, so that's taking me left. 1, 2, 3. And if I did it again, rise 2, run 3, it's going to take me off my board because that would be over there. Now let me use this slope, and I'll just show you a point back in the opposite direction. Starting from my y-intercept again right here, I would rise negative 2. A negative rise takes me down 2, and then I'd run positive 3. 1, 2, 3, so that would be a point there. Okay, and I'm not going to go any farther because it's just going to take me off the grid. All right, I hope this helps you getting ready for the Unit 4 test.